Yo! Hopefully I'm live. I think I should be good. You guys are doing good. Life's good. Welcome. How was period one? Who showered today? You can see that's my question of the day. Yeah, sorry. I decided to brush my teeth today, which is good. That's an essential part of this. I was talking about how I was basically right before period one. You just like, you can sleep in a little bit longer. I had my coffee that I made just in my kitchen over there for period one. Life is good, taking things easy. And then I was like, I didn't, like the whole time during period one, I'm like, I didn't brush my teeth. What's wrong with you? So anyways, I brush it now. This is the best thing about being at home. You can brush your teeth whenever. Okay, so y'all, you showered, good call. I'm not gonna, okay, I didn't. I showered last night before bed, so anyways, my hair's a little bit poofy today. I apologize. Logan, it says error for you. Can you refresh maybe? Liam showered yesterday. This is maybe too personal of a question. I apologize. Yeah, do you like my curtains? These are, so like this old lady used to live in this house. Anyways, everything is super old school. I should show you my chair as well. It's a bit embarrassing, but anyways, you can see the ferns, and also like the pillows on the couch are the same like fern like pattern. It's like the ugliest thing. There used to be curtains above the window that were the same, like with the fern like pattern. So there's and the couches on cushions on my couch are the same as well. So there is a lot of embarrassing little things. Maybe I'll give you guys a tour at the end of class or something like that. But yeah, kind of embarrassing. Actually, this screen, there's not enough light just yet. This the blinds, they're almost a green, so I've set it up that I can. It doesn't work so good. It's just not bright enough. But when it is bright enough, I'll be able to like green screen it so you get the see-through behind me. I'm hoping that works. But anyways, yeah, thanks y'all. It's not that fashionable, but that's great. Some white kid K showered last week. Whoa, what the heck? Shower 2 times a day, sometimes 3? Do you like work out a lot? What the heck? Okay, we are starting this sucker. Let me just close down a few things. I can probably do attendance at this point. Yeah, all right, right on. Let's do this thing. Boop, 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 boop. Hit me up in the chat if you're here. Give me your name. Just type your name, and maybe so I don't have to scroll back up. Just give me your name. So hit me up with your name, and that would be lovely. Let me just grab the YouTube chat somewhere here. Where am I looking for that? I'm going to do a little pop out. Okay, so I see Paula is here. Awesome, thanks Paula. Liam I saw is there. Love it. Hugh is here. Thanks Hugh, welcome. Hopefully the dorm Wi-Fi is better today. Yalda's here. Izzy's here. Awesome. I might miss some people. I might have to scroll back up. Please don't type too much. Else if I can't see you here. Yalda, Izzy's always here. Awesome. Jerry is here. Jerry, where are you, bud? Awesome. Perfect. Daniel's here. Did I already do Daniel? No. Awesome. Okay, we're good. Who am I missing? Crystal's here. Awesome. Dylan. All right, thanks, Logs. Hopefully that is you. Your brother hopefully has better things to do. I don't even know if he's still at home. Is he at home? Daniel, Liam, Wendy's here. Awesome. Oops, David, I'm not sure about. I shouldn't have clicked just yet. Is David, you here, bud? I'm going to mark absent for now just because I screwed that up. Sorry. Paul is here. Thanks, Paul. Lenice is here. Hey, guys. Cam is here. Frig, you know it. Oh, yeah. Thanks, David. Awesome. So I'm waiting on Max. Waiting on Josh Daffé. Kyle. Bassett. Batten. Ty. And, oh, wait. Wasn't like some white kid Ben? Pretty sure that's Ben. I feel like it's Ben. Batten is here. Hey, Batten. Cam, you know those stupid emojis? They're giving me freaking all period one plus still now. That stupid song that, you know, like on Instagram, everyone's doing those dumb, like, I forget, it's like a gesture challenge or something like that when they do like, I don't even want to hum the song because it drives me crazy because everyone is doing it. It makes me want to maybe I will smash my head off the desk, but then you have to like do little gestures and it's like this. Yeah, no, I'm not doing that. It drives me crazy. Anyways, Ben is good. Okay, so who did I see? I saw Batten. Batten, where's your brother? Where's Bassett? So no, I feel like I did see Daffé though. Am I wrong about that? Oh, he's upstairs. Batten, tell him to watch the stream or say something. So I'm gonna mark Max absent, I guess. Ty was here? Okay. Did he say something in chat yet? Oh, Bassett's here. Hey Bassett, welcome, bud. Daffé's here as well. I'm here. Okay, awesome. Thanks, guys. Yeah, doesn't Ty's a different name or something like that? I can't remember. So just no Kyle then. So no Kyle, no Max. Perfect. I don't know how to do that crap. All right, so let's start this sucker. Oh, yeah. That's his name. Hey, it's Slat. I'm not going to try and say that just in case I mispronounce it. Perfect. Awesome. Okay, great. So let's rock and roll. Hopefully attendance is all good. I've got a couple messages. Liam. Oh, yeah, Liam. Found an error in the textbook. Now I'm having a hard time remembering what the error was. Let's actually look at that. Can we open up? Let me just change what you guys can see from me here. Sorry, I'm a noob streamer. I'm not so good at this. Let's go like this. And I think you guys should be able to see this here. And I'm gonna just move the chat back up to my other screen. Sorry, I will get the hang of this eventually. Okay, so you should be able to see me. Oh yeah. Sorry, Daniel. Liam wanted the shout out. Can you guys remind me which question the textbook answer was wrong, so that way I can give you that shout out. But anyways, hopefully you guys can ask questions right now. I think we'll start every class like this. So if you need something from me, ask away in the chat right now if you want me to try. Ethan, welcome. Awesome. That's funny. I don't even know how you found me. I'm sure your sister sent some link or something like that. That's so funny. But welcome, sir. Maybe you can help us with some grade 11 math. 8D. Okay, 8D was one of our problems, right? Okay, so negative 10 to the some white kid is Ben, by the way, Ethan. You can kick his butt at church later. Okay. Sorry, no violence. That's rude. We want to do 8D. 8B, I see from Paul. Awesome. Yeah, so every day at the start of class, guys, if you just want to, in chat, just say which question you want me to do from the homework. And yeah, it looks like a lot of people want 8B and 8D. So we're going to go through those. But it looks like 8D was the mistake. So let's rock and roll from there. Let's just do a little print screenage. I don't think that'll work. But yeah, we'll just do 8B was 8M to the 256. Okay. So let me open up OneNote here. Oh yeah, you guys can't even go to church. You just have to virtually bully each other. All right, so let me just add like a new page. I'll do this in the content library. Just do it like homework help. That way you guys can look at this later. And what page was it last night? So practice. It was like essential skills or something like that, right? Or getting started. And I forget the page itself. The page itself is 212. So 212, 8, B, and D. So we're going to do 8, B, and D. Awesome. Thanks. 8B and D. So if I remember right, 8B was something like 8 to the M equals 256, I believe. Let's just double check that. I got a terrible memory. Yep. And then D was negative 10 to the R equals negative 100 million. I think that's, yeah, negative 100 million. So hopefully I get the right number of zeros on there. Negative 10 to the D equals negative 100. 1, 2, 3, 1, 2, 3. Yeah, that's disgusting. Okay, sorry about that. Okay, sweet. All right, let's do 8B first because I'm not excited for that 8D because my brain doesn't want to think with that many zeros. So we're going to rock and roll with this. So you're basically just guessing. I'm going to teach you guys in a minute how to actually solve these for real. And actually, maybe I'll teach you tomorrow. I think tomorrow is the day that I'm actually going to teach you how to solve these with your calculator. I could do it today. We'll see how she goes. But basically what you're doing, this is kind of the goal in grade 11. You don't actually learn the skill I'll teach you later, which is the log button on your calculator, till grade 12. But it's just kind of dumb. In grade 11, the textbook in Ontario is like, just guess, because there's no other way of solving it. And so you're just going, basically, like 8 to what exponent is 256? And so you just keep trying. Now, I know 8 squared is 64, but we can keep trying things until we get kind of close, right? And that's kind of, I know it sounds kind of dumb. Sorry, let me just open up the calculator app for you guys here. But we're basically looking to say, like 8 to what is 256? So let me just bring the calculator down so you guys can see me being a goof and trying. So we know 8 squared is 64. So if we do 8 cubed, we'd get 512, right? So it's not that, it's too big. So let's try somewhere in the middle, right? 8 to the exponent, and so my exponent button, you guys probably can't see it, it's this little x to the y. 8 to the exponent 2.5, and if we try that, we get 181. So again, that's kind of nasty. So we're gonna do 8 to the exponent, and where the crap is that button again? Okay, there. Let's do like, what did we need to do? Last time we had, I have a bad memory, I think it was 100 and something, so we need to go bigger, right? So 8 to the exponent, we tried 2.5, it wasn't big enough, so we'll do 2.6. We get 222, so we're getting there. And I know this is frustrating, right? So you're basically just trying to get it as close as you can. I'll show you how to do it exactly in a second here, but 8 to the exponent, let's try, we did 2.6, let's do 2.7, right? 274, so we're a little too high. So maybe if we want to get even closer, like to me that's good enough, we'll do 8 to the exponent, 2.6 was too low, 2.7 was too high, so maybe 2.65-ish. And that's pretty darn close, right? You could keep trying numbers to get exactly, but if I try 8 to the exponent 2.65, it's approximately, what was our exact number here? 247.28. 247.28. So pretty nasty, but what was it, 2.8? Yeah, awesome. There is definitely a better way of doing this. And so some white kid says 2.69 is the best. So we could keep trying numbers until we actually get it. Here's how you can actually solve this though. If you wanted to get an exact number, I'm an exact number kind of guy. Maybe you think this guessing game is like absolute garbage. Let's try in our calculators. If you guys try this for a second, if you type in this instead. You might notice there's probably in my calculator, if I'm looking here, there is a button called log. I don't know if you guys have a button on your calculator called log. Hopefully you took my advice and yesterday you looked up the log button. But it is on there somewhere. So if you find the log button, hopefully if your calculator doesn't have it, it might have hidden it. But normally all calculators will have it unless your calculator is not so good. So you're gonna hit the log button. But here's how you use it. This is our first thing here. You take the number that is all on its own. So the big number out here, the 256, and you're gonna do log 256. So you would type log 256. And you divide it by the number, so log still, I'm gonna log, the number that's in the base. So it's like the base and the exponent, right? We've got your base and the exponent. These are words we learned in grade 9 if you were here. But the base here is 8. And so log 8. Hey, welcome, Kyle. I should mark you here. So you get log 256 over log 8. So if you guys type that in your calculator, I'll show you how I do it in mine. So I'm just gonna clear everything. So if you do log 2, I have to type, mine's backwards. I have to do 256 log, that's annoying. 256 log, so I've got the log of that. And I'm gonna divide that by 8 log. It's kind of like dumb and backwards. It will tell me the exact answer. So mine is saying 2.666666. That's, I shouldn't, anyways. But repeated forever. And so like 2 2/3. Well, let's see, does that work then? So if I do, in my calculator, if I try, like if this thing was equal to 2.666 repeated, if we try 8 to the exponent, that 2.666 forever repeated, to the exponent of, and I don't think I have an answer button. It'll be rounded unless I actually keep it there. I'll do as many 6s as I feel like clicking through to make sure it's more exact. But you'll get 256. Oh yeah, 8 over 3. Thanks, Huey. I don't know why we don't just do that. 8 over 3 is the same thing as 2.6666 repeated like that, if you want to do it as a fraction, right? So you can see that we're really close here though, right? But if we take Hugh's advice and we do 8 to the exponent 8 over 3, so I should do brackets here, 8 over 3. Equals 256. So perfect. I was confused for a second. I was like, oh, that's not the right answer. I just hadn't hit equals yet. So that's how you could do it. Now in grade 11, if that was really confusing to you, well, it should have been because I haven't taught you guys what log is yet. Don't panic. Don't stress about that. Basically, it's a way of getting the exact answer because I know a lot of us hate guessing. And I will in grade 12, I'll explain exactly how to do that. But I'm going to explain 8D in a second here. But in grade 11, if you got 2.65, that's more than enough, right? I know it's not exact. The answer is actually 2.66666. But if you got 2.65, we'll be able to solve that one there. So, be able to solve. I'm not making any sense. I've got so much going on with the chat and the stream and then my OneNote, I get a little confused. But if you wrote 2.65 as your answer for this question, that's close enough. Honestly, 2.6 would be a great answer as well because you're pretty close. So in grade 11, you're only expected to be able to guess that close. But if you want exact, because it's a lot easier once you get the process, I think it's faster, you'll be able to do your log 256 over log 8. So let's check 8D. Some people in the chat are saying the textbook's right. We'll try it out. So 8D is negative 10D is negative 100 million. So I know this is how many zeros? 1, 2, 3, 4, 5, 6, 7, 8 zeros. Yowza. Okay, so if you were to choose 8 here, and I think this is probably where the confusion is because a lot of people, holy smokes, sorry, that is like an epic stretch. I needed that in my life. Because there's 8 zeros, if we put our exponent as 8, right? Because you know, like 100, if it was just like 10D equals 100, there's 2 zeros here, so it'd be 10 squared is 100, right? And if there was 10D is 1,000, right? There's 3 zeros, 1, 2, 3, so it'd be 10 to the 3 is 1,000, and so on. But because there's 8 zeros here, I know that it's going to be 8. However, a lot of people get confused with this one, and I think this might be where our problem is. If you're looking here in your exponent, you're looking what exponent should it be. If it is 8, you might think if this was in brackets, right? If the negative 10 was in brackets, that'd be negative 10 times negative 10 an even number of times, right? And you think negative 10 times negative 10 makes positive 100, right? 2 negatives make a positive. So if we have an even number, which we do, of negatives, it would end up being positive. Here's the trick. This is it's not a great question, I guess, but because that is an exponent that is not within the brackets, you're actually just doing negative 10 to the 8. So you'd have 10, I won't write them all out, but you'd have 10 tens. So it'd be negative 100 million, which makes the answer of 8 correct. So if the textbook did say that your D value here was 8, then it would be correct. It is a bit confusing though, and I can see where the problem is. The answer would either be 8, or if it was in brackets here, you'd have to be like, oh, there's no answer, right? It'd be no answer. Does that make sense? Maybe post in the chat if you had any other questions from the homework, or if something there you didn't like that, something weird. Just gonna grab a sip of water here. Hopefully you guys are still with me. We will start the lesson soon. Just want to always give people a chance to ask the homework. Yeah, so the brackets, y'all, they basically have to do with, does the 8, that little exponent that we're going to do, apply to the number, which it is because it's above the number, as well as the negative in front or not. Right now, because the negative is in front and it's not like in brackets, like if it was in brackets, you'd have to have that negative, being included in that. So if it was, if it was brackets here, let's just do like negative 10 to the 8. Well, then it would be negative 10 times negative 10 times negative 10 times negative, like, and so on, and it would be 8 times, but basically it'd be a negative times a negative makes positive. Whereas here, because it's not in the brackets, that exponent doesn't attach to it. So really what's happening instead of this whole nastiness is the fact that you've got this negative in front. Yeah, exactly, it'd be positive, you're right, Yelda. So it'd be this negative there, and then the 10 is multiplying, so it doesn't matter how many 10s you've got. It's like, okay, here's the number, and then afterwards it's just gonna be negative like that. So the negative, because it's not in the brackets, it's just like negative, and then there's 10 eighths. But if it was in the brackets, it'd be negative 10 times negative 10 times negative 10, instead of negative 10, 10, 10, 10, 10, and so on. Guys, what I found works a lot better actually if you guys have like a very personal a personal question for me that you don't want other people to see. Like if you're not comfortable with the chat, and it's like, oh, I don't want other people to see that I don't understand. If you send me a message in Teams, I won't give you a shout out or anything like that. I'll just be like, oh, I had a question about blah, blah, blah. And so I will, sorry, I'm playing with my thing. Sorry. I was like with this. Oh my gosh. So anyways, basically, I'm so stupid. I'll be able to give you a shout out, be able to answer your question or whatever it would be. So that'll be good. Great. All right, let's move on. Let's skedaddle. You guys got any questions for that until we move on? Everyone give me a thumbs up if we're good to start the lesson. What don't you understand? Oh, don't worry, Hugh. I'm glad you don't. No, Logan, don't clip that. No. I have problems. Okay, thumbs up. Thank you. Okay, we're actually going to start with a bit of an activity, which I know is going to be kind of weird, and hopefully you guys follow. But what I'm going to do is, okay, sweet, I've got lots of thumbs up. What I'm going to do is I'm going to play the video for you guys, but it's also included in your OneNote here. And so normally in class, what I do in this activity is I ask you guys to actually, we get rulers, I give you guys ping pong balls, and we actually drop the ball from a certain height. And so what's going to happen is we're going to graph basically the height of the ball per bounce. So instead of like the x-axis being time, the x-axis is going to be the bounce number. So it's like, okay, The first bounce is what height? The second bounce is what height? And you guys can tell, like when you bounce a ball, right, as it comes down, each time it's not going to be as high, right? It's going to get slower and slower. Well, not slower, but it'll bounce till it's basically resting on the ground. So we're going to track the height of a bounce of a ball. And I would have you guys do this in class, or we drop a ping pong ball beside a ruler and actually go ahead and measure that with your iPhones and do slow-mo and then compare everyone's graph. But because we're at home and maybe we don't have that resource available to us, obviously you guys have your phones, but maybe you don't have a ruler or meter stick and a ball, and it's just kind of less fun to drop things on your own at your house. It's kind of weird. I did include the video, so I'm gonna open this for you guys, and we'll play it together, but then you'll probably, sorry, let me, so you can see, right, after the first bounce, the height here was like 8 centimeters. Second bounce looks like it goes to 6.5, something like that, and so on. So here's what I want you guys to do. I want you to watch that video without me. Oh, I don't need to full screen that, sorry. Without me, you don't need that part. But from there, I want you to, in your OneNote, down here, record those heights. So record the heights of the ball at each bounce. I think there's 5 bounces in there, so hopefully you can get at least 5. If you need to add more points, that's great. But then up here, oh shoot. Okay, so because I was dropping, I actually think I remember when I made this in class, we dropped the ball from the top of the ruler, but in this video, it's only 10 centimeters. Sorry about that. So maybe what you guys will have to do is you're gonna have to change this graph. So it says, you know, this is 1, do I have 2, 3, 4, 5, 6, 7, 8, dang, okay, just do it by 2s then, right? So this would be 2 centimeters, 4 centimeters, 6 centimeters, 8 centimeters, 10 centimeters, 12, and you're not even gonna need to go up to 14 and 16, but anyways, 14 and 16 there. Sorry, hopefully that isn't too confusing. So in class, I just dropped it from a higher point on the meter stick than here. So if you guys can, you can start here, get your first bounce, second bounce, third bounce. I'm gonna give you guys some time to do that. I'll be checking in chat, and that'll just be a kind of a little activity. Give me the domain and range of what that function would be as well, and we're gonna take this up, but I want you guys to do this on your own, try it on your own first, and we'll take it up. And then the second challenge would be here, and I will teach, I promise. We'll do this one as well, but see if you can come up with an equation for this question right here. So this one, it's a time, and basically amount of bacteria, and this is a bit of a weird question with the topic now, but anyways, bacteria on my feet. So at time 0, so at this very moment, I have 1 bacteria on my foot. It's probably a lot more than that. After an hour, I have 3. 2 hours, I have 9. After 5 hours, I'm all the way down at 243 bacteria on my feet. So see if you guys can come up with an equation that models the bacteria on my feet as they grow. So give me an equation. So what do you guys think the values of y? Was there some sort of pattern you can come up with an equation, and then see how many would be present after 6 hours to see if we can come up with that. Then I'm just gonna talk for a little bit. I'm gonna give you guys some practice to do, and all's good. So when you're done, both of these questions, can you guys say, I'm done both questions, Mr. Ellis, I'm ready for us to take it up. So if you could do that for me, I'll give you a bit of time here. I think it shouldn't take us longer than 10 minutes. I'll stay with you guys on stream as you're working through that, but let's see how you do. We are working on the first 2 problems from the note. Does that make sense? Probably a lot of you guys muted me and are watching like anime or something like that right now. Rude. Remember, I did change my units here, so sorry about that. Hopefully you guys can do that as well. We will take this up. I'll give you guys some time. Someone wants me to scroll to the second question. Yep, totally, I can do that. Yeah, okay, it's fine. Why do we want to scroll on the second question? I don't know. Yep, okay. You guys should have this, right? Didn't I send this to you guys? Does anyone not have this note? Oh, okay. I'm just gonna go grab a Tylenol, guys. I'll be 1 sec. I'll be right back. Sorry, I should shut up. You guys are working. If you guys have any questions, feel free to remember to message me in Teams or on here. And please let me know when you're done, and so we can take some of these up. Logan, I'm right here. Oh, that's why someone wanted me to scroll it up, because they don't have this in their OneNote. They're just doing math with me. That's fun. Welcome, someone. Yeah, for sure, Ty. Just gonna move, I'm gonna make me full screen. That way when I'm looking at your guys' OneNotes, you guys can't see what I'm doing. I think the first bounce was 10 centimeters from the bottom, or 8. have to, when we take it up, I'll try and be better at that. Some people are saying the graph doesn't look right. It should look like kind of like an exponential function because that's what they've seen it as on. This is Bassett says he's done. Who else wanted me to check there is Jerry. Jerry. Yeah, looks good, bud. Looks good. If you're done, maybe you can extend your graph a little bit as well. Let's see if you can come up with something there. Sweet. Okay. Looks like some people are finishing up. There's a lot of people that are quiet. I haven't heard from a bunch of people in quite a while. Liam, you want me to see if you've done something weird? Yeah, yours looks very straight. It should curve. There should be a bit of a curve on it as it comes down, right? Because I think the ball, like, it starts at 10 centimeters. So you can say at 0, it should be at 10. And then I think at the first bounce, it should be at 8. And then the second bounce, I think it drops to, I can't remember. I'll go and look through that video with you guys. But yeah, I think if your graph is straight, shouldn't be perfectly straight, especially after like the 5th or 6th bounce. Yeah, anyways, someone, whoever that is, you're not gonna be able to do it because you don't have the video. But I can post the link for the video in the chat. Copy link. Oh no, I don't know how to do that. Anyways, somebody else can help me out do that because I'm gonna check. Zoe wanted me to check her graph, and then Kim. Crap. Now when I said, okay, I think when I said I'm back, we're good. Okay, good. Yeah. Just gonna make one last comment. And then we'll try this together. Yalda, yeah, that looks good. That looks really good. Okay. Okay, so let's do this. I gained 11 subs. Oh, amazing. I've seen a lot of graphs. And again, who just messaged me? Sorry. Okay, I'm gonna take it up because I've noticed a bunch of graphs are a bit weird. So I'm gonna watch the video with you guys at the same time that I do this. So let's see. I'm gonna have this on this side, my OneNote on the other side. Let's go. Oh, I can't full screen it. That'd be weird. See how I do here. Just gonna click this maybe. Beauty. Okay. Oh, sorry team. I should not be sharing people's screens with you, but all's good. Okay, let's look at this. Gonna be some time where I get used to this. At the first bounce, let's go back. So they're holding it. The first bounce, I believe, I'm gonna do it by the bottom. You guys might have done it a bit different than me, but I see that it is 8 centimeters high from the bottom. Second bounce, I see 6.5. Third bounce, I see 5.5-ish. Fourth bounce, 4. Fifth bounce, 3.5 maybe. Ish. And then we could measure from there. And you see that basically each time, it looks like it's like, you know, changing by a little bit less every time, right? The biggest change was definitely at the start. It jumped 1.5, right? From here to here, in our first graph, it looks like it jumps 1.5, goes down 1.5. Here it looks like it goes down 1. Here it looks like it goes down 1/2. And then here I'd say it also goes down another 1/2-ish. But anyways, it's hard to get it perfectly right when it's happening so fast. Okay, sorry. Ooh, I'm very close. Oh, shoot. I don't think I was sharing. I wasn't sharing my screen. I suck at this. Sorry, guys. Let's go back to... My bad. You guys probably couldn't see what I was doing there. Sorry. I'll show you that one more time then. Sorry about that. Let's go back to OneNote. Open that video. Just show you what I was looking at. So when I look, I'm looking here and I'm seeing that the ball bounces once. What's its height after it bounced once? I see 8. Second bounce, I'm going to see 4, 5, 6.5. Right, 6.5. It went to 6.5. The third bounce looks like it went to 5.5 to me. Fourth bounce might have been 4. And fifth bounce might have been 3. I would say 3 almost, but 3.5 maybe, something like that. So that's where I got my numbers from. So sorry that I just did all that demonstration behind closed doors. Let me see. You guys probably give me a hard time here. Oh, yeah. Can you show your screen? Yeah, sorry about that, guys. Okay, thank you. My bad. So do you see how I got those numbers now, maybe? Kinda? Hopefully. I just have one little Teams message here. Yeah, we're good. Thanks, Daniel, I needed that. Okay, so let's graph these numbers then. I guess you could say at 0 bounces, the height was 10. So you could put a point at 0 bounces for a height of 10 if you'd like. Doesn't necessarily need it. And I guess I don't need my my YouTube video open anymore, do I? So I'm gonna move this whole screen back up. Don't need that. And come back down here and I will give us the full screen. So we had it 10. And then I'd say our second bounce, or sorry, our first bounce here, second bounce, third bounce, fourth bounce. And we could put more on. More on. First bounce was at 8. Second bounce was at 6.5. So that's a weird one, right? Because here's 6. This would be 7. So 6.5 would actually be about halfway down, right? So it'd be about there. Third bounce is going to be 5.5. So I see 5 and 5.5. Fourth bounce is going to be 4. So fourth bounce is going to be at 4 there. And fifth bounce is going to be at 3.5. That's what I get. Sorry, I've got teachers messaging me. Man, there's a lot of stuff going on in this e-learning crap. It's like crazy. Like 10,000 different messages. I got people at Edsby messaging me, people on Teams messaging me. It's like overwhelming. I thought I was tech savvy, but this is like driving me crazy. We'll get it though. We'll get it. I'll get better. So if we were to connect these now, actually a lot of mine looks almost straight too, so I apologize if I gave you guys a hard time, but I wouldn't say it was perfectly straight. Somehow some of you guys had that thing perfectly straight. And for some reason it was increasing, like your line was going up, which is weird because, you know, you've got like more height. That doesn't make any sense, right? So it should have been like going, oh wow, sorry, you can see my hand zoomed in. Going down. Now it looks like I'd be able to connect my curve nicely, and then mine jumps a bit. And obviously this isn't a perfect scenario, but you'd kind of think, right? Like if I'm looking here, and if I was to draw like a perfect curve going through all these, maybe I'll try and get you to kind of line up a little better. Oh, sorry. Something like that, right? I'm not going to be able to get it perfectly. It'll be like a wave getting through all those points. But in general, if we look, this thing eventually, right? As you get to the end, like if we were to go back to that video, you know when you drop a ping pong ball and like near the end of it, or any ball, it like does these little bounces, right? Almost till it like barely stops. It goes so there'll be a lot of bounces, right, before this thing actually stops. And so the curve kind of, flatten the curve, hello. The curve will start to get flat, right? It'll be really steep because it drops the most, like it changes the most at the start. But near the end, it's not really changing as much, right? And so it's gonna kind of flatten out as you get out here a little bit. And obviously it can never get below zero, right? The ball is never gonna keep bouncing and then go below the ground. That just wouldn't make any sense. So it'll flatten out like that. So we're going to have a couple important things here in terms of our domain and range. From that, I would say the domain, right? You guys could say, in this case, the domain would be XER. And I would say I saw a couple people write greater than 0, and I think that's probably right? X in this case, this would be our number of bounces. And yeah, you can't have a negative number of bounces, just realistically, right? So we'd say that your X is greater than or equals to 0. If we say you can have 0 bounces, I guess you can. And then our range would be the height. And it looks like our range, we're talking about the range, right? It's never going to go negative. It can never be negative, even though it looks like the graph eventually would trend down. But when we move out to the end at like 100 bounce, I don't think it's going to bounce 100 times, but let's pretend it bounces 20 times, right? As we get to those little bounces near the end, it'll be really small. And eventually, yes, it will touch 0 once the thing is dead stopped. So we could say that the height of this thing is going between 10, because that's where I said they dropped it from for me. You might have said 8, whatever, or a different number, but I would say it's between 0, the height being 0, and 10. So I'd say YER, but the height is between 0 and 10. Awesome. Okay, it's 11 o'clock. It's 11 o'clock. How we doing, guys? Are you guys with me? Is this difficult? Spam if you with me, dough. Hit me up. Let me know you're alive. Sorry. This is maybe painful. Yes, good. Love it. Kenoshi's here. So he's all good. Love it. Thank you. Bassett's here. Liam's cool. Love that. So cool. Definition of it. Cam is still making the same emojis. Huey's with me. Izzy. Josh said Izzy. I don't know. Good, easy. Jerry's too easy. Yeah. Yalds is here. Paul. Yeah, buddy. There we go. Yalda gave me a snowman. Kyle's ka-cha. I don't know, Izzy. I don't know what the heck he's talking about. Batten's alive. Paul is good. Awesome. Thank you. Who did I not hear from here? Huey might still be sleeping. Wendy's alive. That's good. There's a few of you. Is Lanice alive? Low main. Crystal, hello, hello. Awesome. Logan says, kill me. Huey dooby doo. Alrighty. Cool. So let's, hey, there he is. Hey, Max. Nice to see you, buddy. Perfect. Actually, I think I got to adjust our attendance again. Remind me to do that. I think pretty well everyone was here then. Perfect. Awesome. So let's finish this up. Did any of you guys maybe see if you can type the equation into chat? Did anyone come up with an equation for this, or what's happening here for our bacteria on my feet? Sorry, I shouldn't say our bacteria. They'd just be mine. That'd be weird if they were our bacteria. But anyone come up with an equation for that? Hit me up. Send in chat if you came up with an equation for the bacteria on the feet. The awkward delay. What's the pattern? What's it look like? What's happening here? Is anyone able to help me out with that? Okay, I feel like you guys are listening. You're just ignoring me here because the delay wasn't this long. So, times 3 every time. Yay, Jerry. Thank you. Thank you. Okay, awesome. So, basically, if we're looking at what's happening here then, right? Yeah, it looks like bacteria multiplies by 3. Oh, Slat says error. Whoa, does that mean my stream is cut out? Hopefully the stream is not cut out. Maybe just getting an error on his calculator. I'm not sure. But yeah, definitely we're multiplying by 3, right? Multiplying by 3. Multiplying by 3. And it looks like it's doing that every time. So I wonder if you guys could come up with an equation, right? If this is x and this is y, if you write y equals, what equation would you guys maybe use? I know it multiplies by 3. Looks like we're starting with 1, right? We take 1 and we're multiplying it by 3 every time. Is there a way that maybe I could put like an x in that somewhere? It wouldn't be 3 times x, right? That wouldn't make any sense because then we'd have 2 times 3 is 6. 3 times 2, or sorry, 3 times, my brain is hurting. 3 times 3 would be 9. 3 times 4 would be 12, right? It doesn't work when we do 3 times x. But I see Paul and Bassett. You guys see when they maybe just you guys didn't know how to type that before, but anyways, good job. They're typing 3 little hat sign x, and that means 3 to the exponent x, right? So actually this thing here, I shouldn't write it all like that, but it should be 1 times 3 to the x, or just 3 to the x, right? X to the power 3. Thanks, Ty. Good job. So yeah, what does that look like? Is that going to make sense? Well, it definitely works for these ones, right? 3 to the power 1, that's 3. 3 to the power x is 2 here, that's 9. 3 squared is 9. 3 to the 3, 27, and so on, right? 3 to the 4, 3 to the 5, all's good. So you're able to definitely get something here in terms of some pattern where we got 3 to the power x. And does it work here, right? 3 to the 0, yeah, that'd be 1, right? So even at 0, we can get 1. So works out perfectly. So what do you notice about the values of y? Well, y in this case, we can give a real pattern, but y equals 3 to the x. Oh, sorry. Dry throat, don't judge. Sorry. It can't go through a camera. How many bacteria would be present after 6 hours? Well, time retracted his message. Anyways, it was right, so all's good. All you have to do, right? X is the number of hours, so we just have to put in X to be 6. So you can just type this in your calculator, y equals 3 to the 6. And Liam tells me that is 729, and I am keen to believe him. Beautiful. Okay. So there's a couple things about this one. You'll notice that like in this graph, things are getting bigger, right? We're actually increasing, and the bacteria on my feet are growing. But in the previous example, it was height, right? And the height was actually going down and going down and going down. And so actually you call that decay. And something, it started with a certain amount and it's going down every time. Now, we don't have the same sort of pattern here, it doesn't look like, at least, because it's not real life, right? Although here I was checking for subtraction, so you could see, what is 8 divided by 6.5, right? To see maybe what the number you're multiplying this by, to like figure out the kind of, what am I dividing to get to here? What am I dividing to get to the next one? But because it's real life, it just won't be a nice exact number. Real life never works out perfect like it does in math, right? Math, it's like always, it goes down by the same amount. It's half its original height every time, something like that. But basically, in this case, it's getting bigger. And so how can you kind of like model these things in something like Desmos or something like an actual graph? And so what I'm going to do is I'm just going to explain this next little part. It's pretty simple. There's just a couple quick words that we need to know. So the two big words, and I don't know if you want to take your highlighter out for me here, are going to be growth and decay. So growth is like the one with my bacteria on my feet, right? They're getting bigger. The number is getting bigger every time. And how does that actually like look in an equation? Well, basically the number of bacteria, right? We're starting with 1 on my feet, and then I'm timesing it by 3, and timesing it by 3, and timesing it by 3. And so we write that as 1 times 3 to the x. And I already wrote this out for you, so nothing new there. But that 1 times 3 to the x, the 1 is actually important, right? Because if I instead had different numbers, I don't even need to go up there, but maybe we started with 10 bacteria, right? Well, the number that would change would be this first one. Oops, that's supposed to be a 0 there, right? It'd be like, oh, I'm having 10 bacteria, and then I'm multiplying it by 3 each time. It's still exponential growth because we're multiplying it by a number. We're not adding a number. That would be more like a linear pattern, right? You're adding a certain number every time. But in this case, you're multiplying it by a number and multiplying it by a number every single time. So it's exponential, which is kind of cool. And so that number in front, in this case, it was 1. In the ball bouncing case, it would have been 10, right? We started with 10, and it's like, okay, let's just pretend we were multiplying it by a half. So it's half of its height, right? You start with 10, multiply by half, it'd be down to 5. Multiply by half would be 2.5, half. And as you keep multiplying, it changes less and less, right? Because you're multiplying by a half. And so it's going to be exponential decay. And that's kind of what the next goal is here, is be looking at decay. Decay is when something gets smaller each time. So how do you actually write an equation for exponential functions when you have a certain amount of things at the start? Well, if you look at our example here, we talked about the bacteria. We started with 1 bacteria. That number we're going to talk about it is amount 0. And you can see in here, I'm going to circle it for you guys. Maybe you can circle it in your OneNotes as well. This is the exponential equation. I'll give you guys a minute to write that down because I don't want to stress you out. Let's give you guys a second to write that, and we'll come back. Cool. So the exponential equation is kind of set up. So this little A0 here, I'm pretty sure I've wrote it somewhere. Yeah, A0 is the initial amount. So it's initial means starting, right? And so think about, it's not like there's an exponent. It's just like that little, oh, David's page doesn't have that part. David, I'll try and copy and paste that to you in a second. Okay, bud? Sorry about that. I don't know why. Let me know if you have a similar problem to David, and I'll try and sort you out in a minute there. But anyways, just pay attention for now, and we'll keep motoring here. So that A0 is the initial amount. So it's how many bacteria you started with, or the initial height of the ball. That 0, I know it's a number, but just think of it like the amount when the time is 0. Just think of it like that. It's like this is a variable. A0, that's like one thing. So I'm saying A0 is 1 bacteria, or A0 is 30 bacteria, or whatever it would be, the starting amount would be. And then they are growing by that little a there, okay? And it's going to be exponential growth as long as that a is bigger than 1. Let's pretend the a was 1, right? Well, then it's like, okay, let's pretend I'm starting with 5 bacteria. Okay, I'm starting with 5 bacteria. And then I'm going to multiply it by 1. So then I'm going to have 5. I'm going to multiply by 1. It'll still be 5, and still 5. And so if it's 1, nothing changes, right? If our little base, doesn't matter what x is. X could be 1,000. It's still 1 to the 1,000 is 1. So 1 is kind of the tipping point, right? If the base is 1 here, nothing changes. But let's pretend our base is 2. So again, we would start with our 5 bacteria. And then if a is 2, right, and x is like number of hours, so we do our 5 bacteria times 2 would be 10 bacteria. And then we multiply that by 2 and be 20 bacteria, and then it would just double and double every time. So as long as that a is like basically bigger than 1, it's gonna get bigger and bigger. So let me just show you that in Edsby or something. Might as well, right? Let's see if I can open up. Sorry, in Edsby. What the crap am I talking about? In Desmos. I'll just show you some patterns here. Desmos. So if I'm looking here, I'm just going to turn this on the projector mode, just maybe helps you guys see a little bit better. So if I want to write an equation, right, I'm going to start with, what did I say, 5 bacteria, and then I'm going to multiply that by some base. So if the base was 1 to the exponent x, right, it's just like always 5 because we're multiplying it by 1. So no matter how many hours have gone by, remember the x-axis would be like hours or something, whatever it is, your variable hours normally, number of bounces, something like that, you're always going to have 5. It doesn't change. But if I make my base bigger than 1, if I make that base 2, for instance, you can see that it gets bigger, right? And I know normally you would just be over here, like just looking at the positive hours, but in general, this graph is increasing, right? As the x-axis gets bigger and bigger and bigger along here, I'll scroll that up so you guys can actually see that. You can see that the graph is going up, right? Because we're doubling it every time. And the cool thing is that 5, that number in front, that's always going to be your y-axis, right? If there was nothing there, if it was just like a 1 there even, like just 2 to the x, we graphed this yesterday, you can see that we started with 1, right? It's this starting amount. It's like there's a 1 in front of here, 1 times that 2 to the x. If I want to start with 2 bacteria, right, I can say 2 times 2 to the x, and that kind of makes sense. So that kind of follows through with that process. If you're looking here, though, if we go back to the 5 bacteria example, in this case it's doubling, or I could say it's tripling every time, or quadrupling, and you can see that it changes my shape just a little bit. It gets steeper, increases faster. But if I was to say, okay, no, the base is not bigger than 1, what happens if it's smaller than 1? I bet you that's your next question. Well, if we did that, let's see if I can make just a half, right? A half or something like that. Well, now we're multiplying 5 by a half, right? If x is 1 here, it'd be 5 times a half. And so it'd be down to like 2.5, and then we'd half it again and half it again. And this is kind of like the height one, right? Where I say you start with something, start with 5, but then we're getting smaller each time. We're multiplying it by a half, or multiplying by a half, that sort of thing. So I'm already up to 11:17. I've talked for quite a while. I'm so sorry about that. But I do just want to give you guys one little example about how we do this. Oops, sorry. I think I messed something up there. I haven't seen a comment from somebody in a long time, which is totally fine because I did ask you guys to keep the chat kind of quiet. But let's just do one example together. And the only difference between growth and decay, you're still going to have the same A0, like whatever the starting amount is. It's just that A value is going to be a little bit different. So I've got 5 practice questions. Oh, I guess there's only 3. Yeah, there's just 3. But let's just try the first one together, and then I'll give you guys some time to do these. So there's hamsters, okay, in a cage. There was 3 hamsters to start. It's kind of some sort of weird love triangle. And each month, the hamster population is going to double. This is be crazy. Your parents would kill you. This is like way too many hamsters. And that's actually pretty fast. Let's not get into that. But anyways, the hamsters are hamstering. They're going crazy. So we're going to write an equation to model this situation. So our starting amount, right? They started at 3. That is your A0, right? A0, that's the starting amount. Remember, we're writing an equation for y being the number of hamsters is equal to A0 times a to the x. And that a value, that's the amount it's increasing by. Mr. Ellis 2020. A value is the amount it's increasing by. So in this case, I see that they are doubling, right? That's getting bigger. And sorry, some of these questions are going to be a bit Englishy for some of you guys. So try your best to keep up with it. But if the hamster population is doubling, basically what that means is that our A value should be 2, right? We're multiplying it by 2 every time. So my equation is going to be y is equal to A0, so 3 hamsters, times 2, it's doubling for every x being the months, right? X is our number of months, and y is really the number of hamsters. So I'm going to give you guys a second, because that's my goal, is that when I do more examples, we didn't do that many examples today where I do an example and then you guys think. I'm going to do a question and then give you guys a minute to copy that. So spam a thumbs up or something like that in the chat when you're ready for me to move on. Maybe some of you are doing split screen or something like that. Remember, you can just drag a window to the left or drag a window to the right. But I just think it'd be harder to see what I'm doing if that's you. So yeah, please try that and then let me know. And then we're going to calculate something in a second here. But yeah, I'll give you a second to copy that down in your OneNotes. And while you're doing that, maybe we'll just calculate the next part, because the next part is just asking us how many hamsters after 8 months, right? So no rush, but I'm just going to write y is equal to 3. Ty, always orange juice, buddy. 3 times 2 to the 8. Calculator, where are you? 3 times 2 to the exponent 8. Oh my gosh. Is that right? Is there 768 hamsters? That's unethical. Seriously, did you guys get 768? Did I do that wrong? That's a lot of freaking hamsters. It's only 8 months. That's 3/4 of a year. That's like a friggin', that's not even a whole school year. You got 768 hamsters. Paul, what is happening with your... It's 48. 48 hamsters. Did I do it wrong? 2 to the exponent 8 is actually pretty big, right? Because we're doubling it 8 times. So it'd be 3 times 2 times 2 times 2 times 2 times like 8 times. So it actually probably makes sense. Jerry wants me to sell the hamsters. To a good home, though, obviously. I probably wouldn't keep them in my fish tank in the classroom with the dead snails. Those snails are not going to be fed for quite a while. Not that I've done that ever, but those snails definitely going to be dead now, if they weren't already. Y'all got 768 as well. Perfect. Awesome. No, this one wouldn't be a linear function because we're doubling each month. So basically, like if I was to do a table of values, let me do a table of values for you guys, right? So X is the number of months, X months, and then Y is hamsters, right? So we start with no months, there's 3 hamsters. And then after 1 month, they doubled, right? They doubled, so now we'd have 6 hamsters. After 2 months, they double again, so we'd have 12 hamsters, right? And then after 3 months, we're at 48 hamsters, right? 4 months, oh, that says 41. 4 months, we're already up to, oh my gosh, 80 and then 16, 96 hamsters. That's a lot of freaking hamsters, right? But we're multiplying it by 2 every single time. So instead of like going and doing all that, you can just make an equation, and that's an exponential equation, right? So you're starting with 3, and it's times 2 for every month. So that's what we did. We said 3 times 2 for every month. So it'd be 8. Does that kind of make sense? You guys got any questions about that? Let me know in the chat. Remember, you can always pause. Okay, so it is 11:25. My goal for you guys tonight I was going to give you more questions to do. Oh, I don't know. Thanks, Jerry. Sorry, 12 times 2 is not 48. 12 times 2 would be 24, and then times 2. I missed a step, didn't I? I went too many. My bad. Sorry about that. Anyways, I'm going to ask you guys to do those next questions. This one here, when you're doing the Dodo Bird example, they started with 5,000, so your A0 would be 5,000, right? But then each year only, so actually this is a crazy story. So Dodo Birds, this is like a real true story. It's crazy. There was some island basically where like most of the Dodo Birds lived. And I don't know if you've ever seen a dodo bird. Let me just Google dodo birds really quick. They're like the coolest looking weirdo animal ever. And they're extinct now. So anyways, that's sad. But sorry, actually, where is my Google Chrome? Oh, I have Google Chrome right here. Just Google dodo bird. The dodo birds are so funny. Basically, they're these little guys right here. But dodo birds were so stupid. Basically, they were on this island, and this boat landed on this island. It crashed. They shipwrecked on this island. And on the island, it was like kind of like one of these like tropical islands where there wasn't like too much wildlife, but they did have dodo birds. So dodo birds can't fly. They're too fat. And basically, they were like the kings of this island because like they were like the only ones to go around, and they were like the alpha predator. Like normally you got like wolves or something they would eat, but they didn't have wolves on the island. It was just dodo birds. So the dodo birds would go around and eat like little bugs and eat other things that they could, like worms and stuff like that, whatever dodo birds eat. But they were like the alpha predator. And so basically, yeah, it does kind of look like a turkey, Jerry. And so it's so funny. So the shipwrecked people, they landed on this island and they were like desperate for food, right? Because they're waiting for like people to show up to save them. And the dodo birds, because they didn't have any other predators, they're so friendly. So they walk right up to the shipwrecked people who are like sitting at their campfire, and the people at the campfire are like, okay. And then they cooked the dodo bird. And the dodo birds were so dumb because they're not used to being eaten or killed. They just like they haven't had that in their entire lives. That dodo birds would constantly walk up, and they were like the easiest hunting of all time. The islanders survived off them, but because they were so dumb and because they were so like easy to capture, they had no other food. They basically ate all the dodo birds, and the dodo bird population died on this island. And anyways, dodo birds are now extinct, and that's not the true full story of dodo birds, but anyways, kind of funny. So we're on the island. This question's about that island, and basically you're starting with 5,000, and so every year in this case, only 3/4 of the dodo birds are going to survive. So that means that like 25% of their population dies off, or a quarter of them dies off. And so how do you make sure that you have that many left? Well, if I have $100 and like I lose 20%, or I want to keep 75%, right? How's the question phrased again? Let me go back to the question. Only 3/4 of them survive, right? If I want to make sure 3/4 of them survive, I multiply it by 3/4. If I want to know, what is 75% of 100, or 3/4 of 100? Think of that word of here is another word for multiply, right? Of is another word for multiply. So if I want to know what 3/4 of 5,000 is, I multiply it by 3/4. If I had something like it was phrased a little bit differently, like this could be phrased as a quarter of the population dies, right? Instead of 3/4 survive, you could say a quarter of the population dies. And so you'd put the same thing in, right? A quarter dies is 3/4 alive, so we're multiplying it by 3/4. So it'd be the same thing that you'd put in for that there. So I'm going to let you guys work on those two problems. I did promise a house tour. I don't know if you guys are still interested in that. Do I think dodo birds were yummy? Probably not. They probably like ate bugs and worms and stuff like that, so they're probably pretty gross. Yeah, it is the little, Cam, yeah, it's a little melon bird from the Ice Age thing, yeah. Little dummies. Ice Age, man, is my favorite. Okay, so hopefully I don't like explode this, but I'm gonna open up here, and we'll see. I don't know if you guys are interested or not, but I'll do the little quick tour for those of you guys that care. If not, feel free to close me down. MTV Cribs. Yeah, I'll give you guys the crib tour here. But yeah, close me down. I'm going to end the stream right after the tour. But yeah, just do those 2 questions for me. I think that'll be enough. We'll take them up. I was going to assign number 2 in the textbook. And it is pretty easy. It's actually this like classic tale. This guy comes to like this king. And the king is like, okay, what do you want? And the guy's like, oh, he shows him a chessboard, and he's like, okay, I want 1 grain of rice on this square of the chessboard, and every like next basic. Oh, sorry, the page number, Yalda, is whatever this note 4.1 is. If you look in your textbook and you look for 4.1, I believe it is right there. I could actually show you on here. But if you go to 4.1, it'll be. I'll write it down in your thing. But if you go to 4.1 and you do number 2, 4.1 number 2, and yeah, we will take up the questions tomorrow. I just got a message from somebody asking for number 2 to 3. I will 100% check theirs, but we also will take them up tomorrow as well. So the page number in your textbook is 216, and anyways, this one is like. Basically, every square, he doubled the amount of rice he had. So the king was like, oh, that's easy. This would be like 2 rice, 4 rice. That's not that many rice. But by the end, it was like a stupid amount. So you guys would be able to figure out how many total rice he had. Okay, so I got a message there on Teams. I will deal with that in a minute. I did promise a quick tour, so I'm going to go and I'm going to unplug. Hopefully, I don't disconnect the stream. You guys still with me? We good? I'm going to go full screen here. I'm going to change this to full screen camera. And let's take off the welcome back part. Okay, team. Let's see it. Wowza. So, I don't have to... There's my view out the window. You guys probably won't be able to see much out there, but a little Catholic school, all empty today. They're not in school either, obviously. The Catholics are resilient, but not that resilient. This is my kitchen. I have not cleaned up after making coffee this morning, so sorry about that. But anyways, there you go. This is what I had for breakfast. See the Crave cereal. Not that healthy, but it is freaking delicious. And then, yeah, anyways, there's the kitchen. Over here is the gaming setup, or the lounge area. I actually just, I took some stuff down. You can see this wall is like the most boring wall of all time. You can see my nasty chairs and stuff again. But anyways, you got the bare wall. I'm gonna hang some art tonight. That's my goal for tonight. I've been doing a lot of work this March break on the house. But yeah, this is the pad here. You can see I've got my little setup with the TV. The speakers are there. The PlayStation 4, ready to rock. I just wish that I played video games still, because I do got a pretty sweet setup. Here's my front porch, and my neighbor's walking out there. I got a couple chairs out on the front porch. She's a beauty. Not many people out there today. I won't show you my bedroom because that's weird, but I will give you the little tour of there's the 2 sinks, because why not, I guess. I don't know. And then you got... here you go. This is the spare bedroom. Yeah. See, look, that art, that's not mine. That the lady left that is like, it's like friggin', I don't know, what's that word? Home Sense art gallery in here. There's a lot of like, and this is, I'll show you this other painting too. It's terrible. Yeah, there you go. Probably no one wants to see the garage, but I don't know, maybe you do. It's dark in here. There you go. There's my garage. It is not so organized right now. But I'll show you what I was doing this whole week. So this whole week, I was like renovating my basement. Because if you notice here, basically like these are the stairs that go downstairs. There's my little setup there. But these stairs will go downstairs. And this is kind of probably where... I'm going to go and I'm going to have Mr. DeGelder probably rent downstairs. So this will be his pad. So it was just like a normal house. It was a normal basement, but we're turning it into an apartment. So this whole March break, as I was isolating and all that other garbage, I was just working on the basement and putting in a kitchen. And so anyways, now I'm downstairs and you can see like this is basically like the living room area where it would be. So he'd have like some sort of TV set up there, but that just used to be a corner. And so we made that into a kitchen. And so yeah, we tiled the floor in there. I'll go over and show you. Anyways, yeah, there you go, a little tour. But not done yet, as you can see. But anyways, we put some of the tile on, put the countertops on. That's where a fridge will go. So he doesn't have say word. I don't know what that means. That vacuum is not going to be there. Anyways, just some little things, and still, like you can see, I've got some tape we got to deal with. I got to do some more tile work and paint and stuff like that. But yeah. Put in the kitchen, all that sort of stuff. So anyways, this is the crib. This would be like his like dining and like work area kind of thing over there. Not like totally done that yet, but you can kind of get a sense. He's got a cool fireplace, and actually a pretty good amount of light in the basement. Sorry, I'll quit being like on MTV Cribs for sure, giving you too much of a tour. And then this would be the bedroom down here, downstairs. Anyways, it's got a window. This is like one of those massive closet-y things, and then it's got that closet, and then my drying rack for clothes, currently empty. But it was a yoga mat, which I've used like once because I don't do yoga. But anyways, I somehow own a yoga mat. And then this is the washroom, which is another weird thing. I don't know why I'm showing you it, but this one's actually nicer down here. Sorry, the fan is on. I didn't need to do that. It's got like the big glass setup, and anyways, it's pretty cool. So there you go. That's the tour. That's it. So I'm going to shut up. Some white kid wants to know where the gaming P setup is. PC. Gaming P. I don't do, Benny, I don't really have a gaming PC, man. I have my iMac, which is like probably insulting for me to compare those two things. But I pretty much just use it as a server to host movies and stuff like that. I don't really game on it anymore, but there's the iMac there. But yeah. And I won't show you my bedroom because I haven't made my bed today. So my mom would be disappointed. Anyways, kids, thanks for watching. It is lunchtime, so I'm going to let you guys go. Or you probably already left me. There's probably not that many people here. But you guys have a great day. You guys are awesome. I don't know what I'm going to make for lunch. Probably make something easy. But yeah, enjoy your day. God bless. Love you guys. And keep her going. Keep it up. Keep smiling. Thanks for the vlog. Yeah, totally. How do I end this sucker? Peace.